Hi there and welcome back to the Lally. In today's video, we will look at how to assemble your own lab bench power supply. Specifically, we will be assembling this RD6018W, testing its features like the voltage and current functions, connecting to it via the mobile app and controlling it. Let's get started. First in line, we have the power supply. This is wrapped like this to protect it from damages during shipping. So this is a 1000-watt power supply and it's rated for 68 volts at 17 amps as shown on the case here. So if we do the math, 17 amps by 68 volts is 1156 watts. This is indeed a 1000 watts power supply. On the back here, we have an inbuilt fan that helps with active cooling. And then we can shift this button here between 230 and 110. So if you live in a country where you use 110 volts with the AC, shift this down to 110. But I live in a country with 230 volts AC, so I would go ahead and leave this at 230 volts. On this side, we have the connectors for power. These first three are for the AC power, which is the live, the neutral, and the earth as indicated on the top. And the remaining are for the positive and negative of the DC output. Next in line is the S800 case that comes with the package. And the remaining parts are also inside this case. So let's take a look inside. So here we have the star of the show, which is the RD6018 power unit. This is called the 6018 because it has 60 volts as its maximum output voltage and 18 amps as its maximum output current. Hence the name RD6018. The W is for Wi-Fi. If you buy the version with the Wi-Fi, you get the name RD6018W with an extra Wi-Fi module that allows you to connect to this through Wi-Fi using a mobile app that is provided by this company. If you buy the normal version, which is the one without the Wi-Fi, you get the RD6018. They do pretty much the same thing. Over here we have the rest of the accessories. So in here we have cables that allow us to connect the input to the input of the power supply and then the output of the power supply to the input of this unit. The female input plug, a switch, gummy things that become the stands for the under part of the case. Let's take a look under the hood. So this is where you connect the output of the power supply. So you just plug in these wires and then screw them up and then fix it back in here like that. This is the input filter and that's the output filter. We have a fuse here, a 25 amp fuse. And then there is a space here that has been provided for when this fuse gets blown or gets damaged. So you have a spare fuse in the box. So you just have to take this spare fuse and then insert it in here in this space that has been made available. Or if you want to make it more permanent, you can just desolder the damaged fuse and then solder the spare one in here. And there's also another fuse here, but this is for the output. So this is the input fuse and this is the output fuse. They are both 25 amps. So this also has a separate space that is available for when this gets damaged. We have the fan for active cooling. This is where you connect the temperature sensor. You can see by the temperature mark at the top of this connector. Here we have the CR1220 battery. This is a coin cell battery, but I don't have one at the moment, so I would not be installing a battery in this space. But from what I've read so far, the absence of the battery is not going to affect the operation of this device. So for the rest of the things in the box, we have the sensor itself, ESP12F module that is going to serve as the access point for connecting to and controlling the device. And then we have the fuse, the spare fuse. So this is how small it is. And then we have some extra clips. So let's begin by first installing the stands. So there are two types of screws. There is the countersunk version and then the flat head version. So we will use the flat heads for this part. Next, we install the female connector and the switch. So this would have this part go in this way, and then this will have these two legs go towards this side. So you have it like this. So first you would have to press this and then push and then release. It's stuck and cannot go back out that way unless you once again press this and then push forward. We'll need to screw this, so we have to use the countersunk screws. Next, we have the sensor extension cable upright. That's pretty much it. So we have live, we have neutral, earth. So this is written as an L, an N, and then the earth symbol. We'll connect the wires according to the colors we have here. But then we also have to connect the live to the switch, and then from the switch to the power supply. We will do that by connecting this here to the first pin, and then connect this here to this, like this. This is blue, so this is for neutral. So this goes here. This is the other live wire, so this would go here. So we are left with the earth wire. And so in the end, this is the wiring we have. So if you place the power supply in this manner, where the last end holes align with the holes here, you will realize that these holes under the power supply also align similarly, like this. So this is my cat. His name is Iro. So for cable management, I'm going to use these straps that come with new electronics, especially chargers when you buy them. I don't have zip ties at the moment. So now let's proceed to connect the power to the module itself. So we'll go ahead and remove this piece and then proceed with the wiring. So let's test what we've done so far to see if it's correct before we go ahead to connect it to the main module. So we are going to use this connector. So after powering it up, we see the green LED down there is on. So we have to insert this into this space. And I believe that is it. You have to make sure the part with the raised markings go into the part with the space. So you have to make sure you flash it in this way and not that way or that way. Let's go ahead and test this again one more time before we close it up officially. And we can see here it indicates the input is 68.47 volts. So let's go ahead and close this up. This side has to come to the front because the air will be sucked into this end through the power supply and then out through the back. So this is how it needs to be. Now let's begin checking out the features one after the other. So some of you might be wondering why I did not leave this thermistor inside the case as shown in some YouTube videos out there. The reason is because the thermistor or temperature sensor is not meant to be left inside the case. This is to be connected outside, and then during times when you use this unit for charging batteries, for instance, stick this onto the batteries you are charging so that when the batteries warm up, the unit knows to regulate the power output to the batteries so that the batteries can charge efficiently without damaging them. So that is why this is here. So let's first start by testing the maximum and minimum voltage and current values this system can give out. To set the voltage, we go to V-set, we press it once, and you can see the cursor here, and then we can use this to move the cursor forward or backwards. So we'll move it forward to this side and then use this knob here to increase it all the way to the highest value we can find. So this is 61. Press enter once we have the voltage we want for the output. So that's 61 volts as seen here. And then we can also go ahead to set the current. So let's see how high we can go with current. So we also press I set here once, and then we move the cursor to this side, and then we dial this up, and then this also ends at 18.1. To make sure this shows up at the output, we have to press this on off button. That engages the output for whatever value you set here to actually be given out here. So we'll go ahead and press this. You can see here this indicates 61.01 volt, which is what we set it for on here. But we'll go ahead and double check to be sure what we are seeing here is actually what is coming out with the multimeter. So as we can see here, this indicates 61.0 volts. So this is accurate. So we'll go ahead and turn this off and then set the voltage to the minimum. So this is 00, but we'll just set this to 1, and here we go. So over here we have 1 volt, 1.002 volts. We can also set it to 0 if we want, but over here we can see 4.1 millivolts, which is 0.004 volts. From time to time, we would have to store our configurations in memory so that we can retrieve them at a later time to cut down the time it takes to set voltage values and current values for specific projects or specific boards that we are working with. So for instance, for microcontrollers, most of them work with 5 volts. Some of them also work at 3.3 volts. So let's just go ahead and create 2 configurations for 5 volts and 3 volts, store them and retrieve them, just to show how to store and retrieve values or configurations on the RD6018. First of all, we have to set the values. So let's set the voltage value to 5 volts. Let's set the current value to just 1 amp. What we need to do to save this is press memory and then press any one of these numbers here. So we have from M1 to M9. So I'll just store this particular settings inside M1. It would ask me to confirm whether I want to store the value inside M1. So the red marker here indicates that the correct sign is what has been selected. I can also move this toggle between whether to cancel or to select. So then I'll just go ahead and press enter to save that. I have now used memory space 1 to store values for 5 volts and 1 amp. So that is that. Now let's proceed to store that of 3.3 volts at, let's say, 0.5 amp. So let's do that. Now and store this also inside number 2. So we press memory once and then we press 2 and then we just confirm by pressing enter. So that is that. It is stored. All we need to do to work with 5 volts devices is to just press shift once and then press 1. It will ask us to retrieve 5 volts at 1 amp at maximum voltage cutoff of 62 and a maximum current cutoff at 18.2. So if this is what we want, we press enter, and then you can see that automatically 5 volts 1 amp is set. And then if we want to do the 3.3, we do the same thing. We press shift once, 2, enter, and then the same thing. You can see 3 is also set. So sometimes while working on a project, you mistakenly turn the output knob or mistakenly touch something that leads to the increase of the output voltage or output current that could damage something. So to prevent that, there is a lock feature in here that allows us to lock the buttons, and nothing works in lock mode unless you unlock. So we'll just go ahead and set the output to be live, and then you notice that you can still go to VSet while the output is live and then be changing the values. We are now going to put this inside lock mode and then witness how that also works. To do lock mode, you just press shift once and then you press this lock button or this period button here. You notice the yellow padlock here at the top. Initially it was white. The output doesn't work anymore. If you press this, it just tells you to perform the unlock procedure before you can use these buttons. So in lock mode, none of these buttons work except for the power button, which is the on and off button. Even this button does not work in lock mode. So now let's unlock. You press shift once again and then you press lock again. The padlock up here becomes white. So now you realize this starts working. And then your VSet works, your iSet also works. So let's now quickly hop into menu and take a look at the various options available and what they mean. So to go into menu, you press shift once and then you press the 0 button here or the menu button here. So here we are in menu. To start jumping from row to row, you just have to press enter once, and then you see the highlighter, the red highlighter here, and then you can just use this arrow keys to move up and down to whichever option you want. So we'll just start up here. This is tick OK. So tick OK simply means that anytime you call any configuration from memory, it's going to ask you to confirm that configuration as the parameters you want to set. So when you call a particular value, it will ask you yes or no. So you have to select yes, that you want to actually set this to that parameter, and then those parameters would come. Just like we saw earlier with our previous calls from memory. We go to the next option, which is tick out. So tick out is basically saying anytime you call a particular configuration from memory and confirm that configuration as the parameters you want to set, the output is automatically going to be turned on. So without you pressing this particular button here, which is the on and off button for the output here, the output is automatically going to be active just when you select or confirm that the values or parameters you are calling from memory should be set. So you don't have to press this for that to happen. But the downside of leaving or turning this on is that it is going to probably end up damaging something. If you happen to forget and connect something that requires a lower power to the output while you call a higher configuration for memory, that thing could get damaged. So this is by default left off. So the next in line is boot power or boot POW. So basically this is saying anytime you turn on your system, if this option is on, it is automatically going to engage the output. So as soon as this system turns on, whatever voltage or current parameters you left as your last set parameters would be used to engage the output, whether or not you've pressed this button. So the output is going to be active right on startup. And I don't think that is also cool, because sometimes we might forget and leave projects connected to the output. So it's good to leave this off so that you knowingly have to press this each time for the output to be active. So let's just go ahead and leave that as off. So buzzer. So this is basically all the sounds you hear. So when this goes off, it means that anytime you rotate the knob, as I'm doing now, you won't hear any sound. But if this is on, as it is now, when you rotate the knob, you would hear the beeping sound. The next in line is logo. So if we turn this off like this, when this system boots up, it's not going to show the RIDEN logo it shows in the beginning. Let's just go ahead and just test that out. To save this particular option, you press this knob down once. So that is that. This is saved, and then you can press this again down to exit this menu. So we'll press it again. Turn this off, and then when we turn it back on, the RIDEN logo won't show this time, unlike it was in the beginning. So let's just go back here, turn it back on, save, go out, turn the system off, and then turn it back on. And then this time around it's going to show the RIDEN logo just as it was in the beginning. Over here, you just get to change the language: Chinese, English. I think there are a couple of languages available. English, we'll just stick to English for now. This is for the backlight, so this is for the brightness of the screen. The max is 5, but then it also goes down to 0. Let's just leave it at a 4 because that would end up preserving the LEDs that illuminate this particular panel, so we don't want to run it at max brightness forever. So for interfaces, you can select between USB, so this USB port here. If you want to engage this USB, you select USB, that makes it active, and then now you can connect this to your PC and then use your RIDEN power supply with your PC. If you toggle this to Wi-Fi, it now engages the Wi-Fi chip that we installed earlier to make it active. And then we have TTL, which is transistor to transistor logic, and then we have serial communication, which is the RS485, and I think those are the 4 interfaces available. So for now, we'll just leave it at USB. So if you would like to change your date and time, this is where you change your date and time, and once you are done with your date and time and save, this value will now be saved and run by the coin cell battery in there, so that this time is continuously correct each time you turn on your power supply. Here we have upload rate. This also simply means refresh rate. So this is basically the refresh rate of the values you see on the screen. So this is currently set to slow. This is between slow, middle, and high. Let's just go ahead and keep it at a moderate middle, and then over here we can see the power that is allowed. So you can see the power can be turned down all the way to a very small value. So let's just turn it down and see what's the least. So the least we can have is 10 watts. I for one want to run my unit at a lower max output power than what it is rated for, because I want to be able to preserve my system for a very long time. So I'll just keep it at a reasonable 800 watts, which is 200 watts below what it's actually rated for. So that is that. Save, and we are out of there. What you see here is one of the various styles, or one of the 2 view styles that are available. The other style is the graph, so that will just show you a graph of the output at any point in time. So let's just take a look at that. So we go to shift, go to menu, and then we press this button once. So that will just shift from this gear, which is the menu we have here, to the home option. So let's just shift once to the home option, and then this is what we are currently using. So V out, I out with the rest of the details. We want to press enter once and then shift to this, and then select that and then exit. The view of the output changes. So now if we engage the output, a graph is being drawn of the output. The thermistor indicates a temperature of about 26 degrees Celsius, so that is that. And you can also rotate this to actually change the ordinates, X and Y ordinates of the graph, to make it bigger or to make it smaller if we want to be able to see something clearly. If we change the settings for voltage, it's going to reflect in the graph as well. So let's just say you really messed up your configuration and not very sure how to set it back to what it was in the beginning. How do you reset your unit? And to do that, you just have to turn off your unit. You turn the switch on the back to the off state. You hold this 0 button. You turn the switch back on. So when you turn the switch back on, the unit starts automatically. It resets itself. To confirm that, we'll just go to menu and then check. Initially, I set this refresh rate to middle, but you can see it's now returned to slow. And the power output I set to 900 watts. This is also returned to 1110. One thing I noticed, however, is that the reset of the unit only affects settings. It doesn't affect the values you have in memory or the configurations you have stored in the memory. So for instance, we stored 5 volts at 1 amp in memory space 1. So when we retrieve it, you can see it's still there, 5 volts, 1 amp. So to use the mobile app, first we need to download the mobile app from Play Store. So we'll go to Play Store and then we type in here RD power. So you can see here RD power. So that's the first one. So we'll install. So when the software starts, this is what we have. So access photos and media on. I would deny this. I'll deny this. Agree. At this point, this is what we see in the app. Next thing, we need to put the unit into Wi-Fi mode. We go into menu, and then we skip to this side, the interface side, and then we change interface to Wi-Fi. So when we are done, we select this and we save and exit. So now you can see the Wi-Fi logo is up here. So the next thing we have to do is we have to turn off this system and then turn it back on. You can see it is now in Wi-Fi config mode. It's waiting for a server IP. We open the app. So now we go here in menu and then we select network distribution. So network distribution is asking me to enter the password of my home Wi-Fi. So next thing is initialize. After entering my home Wi-Fi password, I notice a particular IP address shows up here and the same thing shows up here. So that must mean this phone must have sent that information to the unit in here, which is why it's also connecting to the same Wi-Fi. So I'll just go ahead and select this checkbox here that says device displays server IP. So I'll just check this and select confirm. This would go ahead to also show some new values here. Distribution network completed. So okay, it brings me back to this screen. I need to press the connect button here to officially connect. And then I begin to see the same values that are showing up here. So you can see the graph begins to move. So let's just go ahead and set the output. So after that, we can set the output to live by pressing this button. So let's see how that affects that. Yes, so after pressing it, we can see this also comes on, which means that the app works as it should. So voltage, let's shift the voltage cursor here and set the voltage to 5 volts, or 6 is okay. So 6 volts and current at 1 amp. So 6 volts at 1 amp, set. And each time you set the value and don't press set before you go on to the next thing, whatever you just did is lost. So you have to press set for everything you do before you move on to the next. So as I'm done with this, I need to press set for it to be set before I move on. So as you can see, this now works. So we have other parameters down here like temperature, battery, output, wattage, and such. So I noticed while we are using the app, we are unable to use the unit itself. So nothing here works. Okay, so that is that for the mobile app part. In future videos, I will conduct extensive tests with this unit connected to different loads to see how it holds up. I've included links in the description to all the tools, materials, and equipment you saw in this video. Kindly give us a thumbs up to show your support. Subscribe to stay in touch on how to design and build more cool stuff. See you next time.